Yeah, it's really nice to be here, and I'm looking forward to now present some of my research. So I will talk about the acceptance of decentralized water reuse, and I will take their psychological perspective. But I decided to talk a bit before about ERWAG. That's the place where I work, and also the research that we are doing in our group. And I decided to do that mainly because ERWAG is a very interdisciplinary place, and because we are here at interdisciplinary summer school, I thought that might be a nice background. So what is ERWAG? ERWAG is the Swiss Federal Institute of Aquatic Science and Technology. So it's based in Switzerland, just outside of Zurich. And we have there 4 core themes or topics that we are working at. So the first one is aquatic biodiversity, and specifically the biodiversity crisis that we are facing. The second one is climate crisis, and there the impact of the climate crisis on water. So these are kind of the key challenges that we are addressing. The third topic is circular economy and how we can make the closing of the material and the energy cycles more sustainable. And then the fourth topic is health and well-being through water. Being an aquatic science and technology institute, as you can imagine, most of the 12 departments that we have are from natural sciences and engineering. But there is one department, which is the environmental social sciences department, that is actually not natural sciences or engineering. And in there we have 6 different groups: environmental economics, decision analysis, sustainability transitions, policy analysis, and the last one is doing research on inter- and transdisciplinary research, and also accompanying inter- and transdisciplinary research projects. And the 6th one is the group that I'm leading, which is the environmental health psychology group. So what do we do there? The starting point of our research are basically the same challenges and topics that ERWAG as a whole is looking at. But while the rest of ERWAG or the other departments are really looking at those topics from a natural science and technology perspective, we take into consideration more the human dimension. So what do I mean with that? As you all know, climate change, but also biodiversity loss, is primarily caused by us human beings, by our behavior, our decisions, and so on. But at the same time, we can also be the solutions to those problems. And we don't need only the technologies, but we also need people to accept them and use them. At the same time, it's also humans that are then suffering from the consequences of climate change or biodiversity loss, and because of that, then also have to adapt to protect themselves from these changes. And this is basically where our research starts at. So the main contribution of our group is that we want, with our research, to contribute to environmental health protection. What exactly do we mean with that? Especially environmental health, there are quite a lot of different definitions out there, also depending on the discipline. So what we understand when we say environmental health, it's that part of human health that is determined by the natural and built environment. So it's not the health of the environment, but it's part of human health. And accordingly, there are also 2 parts of environmental health protection. I'm sure you know the terms here. The first one is mitigation. So how can we bring people to reduce environmental degradation? And if environmental degradation has happened, how can we motivate them to invest in adaptation? So how can we motivate them to protect themselves from environmental degradation? Of course, for both of these aspects, we need technological solutions. But in the end, it's also humans that have to use them and accept them. And that's basically what we are looking at. So we are interested in the psychological determinants of environmental health protection. And this could be, for example, questions such as, what are the factors that bring people to change their food habits, to go to a more sustainable, to buy more sustainable food products? Or how does someone decide to build a green roof on their house and others don't? Or why do unfortunately, a majority of people in Switzerland decide to vote against a CO2 law, which would have been really important, but unfortunately, it didn't pass. So these are the topics that we are interested in. There are a lot of different psychological determinants out there that we could research, and so we have to focus on a few. And in our group, it's basically 4 topics or theory fields that we are focusing at. I just mention them quickly so that you're aware, and also if something sounds interesting, you can come back later on and also ask a bit more. So at the core is perceived cost, risks, and benefits, because they're kind of very close determinants of behavior change, but then also of acceptance of technologies and policies. But we are mainly interested in the 3 concepts that you see around. The upper one is core values. Core values are overarching goals that people have in their lives, and they define basically how we see the world and what is important to us, and are, because of that, also relevant of what costs, risks, and benefits we perceive and what they mean. So for example, if I don't care about nature, I can learn about risks for nature, but it won't affect my behavior because I don't care about it, right? The second one, I will talk about this one longer also so in the talk, is perceived distributive fairness. I will introduce that later. And the last concept is psychological ownership, where Gertje is also doing research on. We share that. And here it's basically, we look into this, or we are doing research on this topic because especially when we look into mitigation, there it's really that everyone has to contribute. So it's a joint, we need everyone to be on board. But the tricky thing is, with mitigation, it's usually at a person's cost. A person has to invest, but then everyone profits, or maybe even future generations profit. So this is this issue of a commons dilemma. And so we need some measures on how we can bring people to invest also personal, or to be willing to have some personal costs for the community. And one factor is psychological ownership, which is basically collective psychological ownership, is a shared feeling that we jointly own something. And because of that, also care for it and are willing to invest. And this can also be a natural resource. So it doesn't have to be necessarily related to legal ownership. So these are the core concepts that we are focusing on. In the talk now, I will focus on perceived cost, risks, and benefits, and perceived distributive fairness. And with that, I come to the actual topic, which is, the long version would be decentralized wastewater treatment and reuse. I shorten it now to decentralized water reuse. And it nicely relates actually to the core topics, namely to 3 of them. So climate change crisis, how we can close the material and the energy cycle, and it also has implications for health and well-being. And this topic is actually, so water reuse technologies are researched by the engineering group at EAWAG. So we have on our campus this fancy building where in the basement the engineers have their laboratory where they work on greywater recycling technologies and then test them in these buildings. So this is a living lab where people work and live in, and they then try to improve the technologies to then be implemented elsewhere. So while they take the engineering perspective, what we did is then a research project where we looked at the human dimension of water reuse. But why do we even need decentralized water reuse? So with that, for that to understand that, I would like to first quickly talk about the conventional urban water system, especially in the global north, but also many cities in middle-income countries or the global south. So kind of the general urban water system works like that. We take water from the environment, we treat it, store it, then distribute it to factories, but also households, and then the wastewater is collected in sewage systems, treated, and released back into nature. So that's kind of the standard that we have, especially in the global north. This has worked for quite a while, quite nicely, but there are a few challenges. The first one being that quite a lot of the sewage system is old and has to be replaced. And this is quite expensive because you have to dig up everything, replace the pipes, and so on. So not so nice to do. The second one is that especially in low and middle income countries, there has been a huge influx of population or increase in population in urban areas. And this increase has been so big that the system, that the conventional system, the centralized system that is there, cannot deal with the amount of wastewater coming in, or it also doesn't reach all the settlements that are built. And the third point is climate change, and with that related water scarcity. So fresh water is more and more really a precious resource. And that means also that it might not be the best idea to use fresh water, for example, to flush the toilet. So water reuse, decentralized water reuse can be a solution to all these topics. So what do we mean with that? So it's basically that, so I will focus on these 2 points here, the black water and gray water, that the wastewater in a house, which is, so black water is the water from the toilets, gray water is all the other wastewater that is produced, so from sinks, laundry machines, and so on. And the idea is basically that instead of sending this back to a central treatment plant, it's treated on site and then directly reused on site, for example, for irrigation, for clothes washing, toilet flushing, but sometimes even also then for potable reuse. And with this approach, we can actually address all those issues, because if we do part of the whole water treatment decentralized, we don't have to replace all the old infrastructure. We can also replace part or cover part of the volume that comes with wastewater with decentralized treatment plants, and we can use this water for, so we can save fresh water because we reuse the wastewater in this cycle. So because of that, because this is really a great approach, there have been some municipalities that have mandated this decentralized wastewater reuse. So in Bengaluru in India and also in San Francisco in the US, there are policies in place that mandate part of the population to use those systems. Why did they decide to do that? So in Bengaluru, the reason is really this growth in population. So as you can see here, they had from 2001 to 2022 more than double the size in population. It's still expected to increase. And what you can see down here is that in 2001, the population was most dense in the center. 2011, this completely flipped, and it's now the population density is really outside in the outskirts. But the sewage network is actually only in the middle. So this means for quite some years, all the people living out here, the entire wastewater that they produced was just released into nature, which really then caused a lot of pollution, which is one reason why they wanted a solution for that. But on top of that, also because of the population growth, there is less and less fresh water available. So they have really issues on the water side by now as well, which is why then they decided to have this policy that mandates the water reuse. In San Francisco, the situation is a bit different. There it's really caused by water scarcity. So they have, because of climate change, more and more droughts that are really severe. And because of that, they really decided that they have to replace some of the freshwater consumption with this reuse of wastewater. And this is why they also came up with a policy that mandates part of the population to use these technologies. So maybe we could just think, okay, we install these technologies, problem solved, we can go forward, deal with something different. Unfortunately, so this is now the case in Bengaluru, that's not always the case. So you can have a technology, you can even have a policy, but that doesn't mean that then it's really implemented properly. So especially in Bengaluru, there are a lot. So there have been more than 3,000 decentralized wastewater treatment plants installed, and they are supposed to also reuse the water. The reality is that many of them are not operated, maintained, and monitored properly. The water that is then, the treated water, is of so bad quality that in many cases, people then decided to release the water again into nature because they were not willing to reuse it. And yeah, it didn't really work in practice. So why could this be the case? Maybe it's simply because people don't like the technology. So they could just not be in favor of it, and they have to install it because they are forced, but then they are not willing to invest into the monitoring, maintenance, and operation of it. Or it could also be that they actually don't like the policy. They are fine with the technology, but because the policy really pushes it on them, then they're like, yeah, no, I don't want to invest in that because I don't like the policy. And so in Bengaluru, it was indeed the case that there have been rallies and protests for part of that. So it was quite an extended policy, and there were quite a lot of protests, and they then also had to kind of simplify it a bit and leave some buildings out to just deal with the protest. And so this is now where we are interested in, is not so much whether acceptance of technology and the policy are really the cause of maybe that, or the lack in this is the cause why it's not working properly, but we were interested in the factors that explain the acceptance of the technology and also the policy. I will now first talk about technology acceptance, and we researched that in Bengaluru. We did that through an online study. With inhabitants of Bengaluru, we recruited them with a panel company. So it was an online questionnaire that they filled in at home. And the questionnaire was distributed about mandate among people covered, so mandated users, but also people not affected, because we were also interested in their perceptions. And what we measured were the perceived costs, risks, and benefits of these reuse systems, and we were then interested in how they relate to the acceptance of the reuse systems. What you can see here on the left side are the costs and risks that we assessed, and on the right side, the benefits, and it was quite a diverse range, so financial risks, noise nuisance, space constraints. And on the benefit side, we have a positive image, water security, but also less wastewater that ends up in the environments. Among the costs and risks, the two that were most strongly perceived were the responsibility for the operation, monitoring, and maintenance, which is a huge difference. So when you have a centralized system, you don't have to deal with anything of that, right? But then when you are forced to have the system at home, it's suddenly in your responsibility. And then the second one was the monetary costs for installation, which in Bengaluru was really, the users had to deal with this, so it was not that the municipality paid for it or anything. When we look at the benefits that were most strongly perceived were a positive image that you can gain when you use such a system, and also less wastewater that ends up in the environment. So as said, what we were most interested in is how these are now related with acceptance. And for that, we correlated them and then also run some regression analysis that you can see now here. And the first interesting thing is actually from the costs and risks, we had no associations with acceptance. So if someone perceived higher environmental risks, it was less likely that the person accepts the technology as the person doesn't accept the technology. So the two factors that were the best predictors of acceptance were first environmental benefit. So the more people perceived that these systems are beneficial for the environment, the more they also accepted them. And the second one, this positive image for users. So what can we conclude from that? So the first one is that the costs and risks does not seem to be necessarily a barrier to technology acceptance. So what seems much more important are the benefits. And what can we learn from that also for communication attempts is that we really should probably focus best on these benefits. And the first one is really the environmental benefits that these technologies have. So emphasize those in communication, but also work with this positive image and maybe have a campaign around being a green hero when you adopt these technologies. So with that, I will now go to the second topic, which is the acceptance of the policy. And here, so in both cases, as I said before, in Bengaluru, but also in San Francisco, it was that only part of the people had to adopt the technology. It was in both cases, it's houses above a certain size, so it's not single households. And in Bengaluru, it was mostly middle income and high income people. In San Francisco, mostly high income buildings. The fact that it's only part of the population that has to do this causes concerns or might cause concerns for distributive fairness. So distributive fairness is really about how the cake is distributed. So who receives the benefits? Who has to pay for it? Who has potential risks? And so one key fairness principle is equality. And with this policy, because only part of the population has to do it, it's not equal, because equality would mean that everybody's treated the same way. It's not the case. A second key principle is equity. That means that you should get as much out as you invest. Again, here not really the case, because the costs occur mainly to those covered by the policy. They have to pay for it, while the entire population can benefit from it. However, there is also this fairness principle of needs. So maybe it's not necessarily that those who contribute more should also get more out. Maybe it's that some people cannot contribute that much, but they would need quite a lot. These could be vulnerable groups such as low-income people, but also in this case now people most affected by water scarcity. While these are kind of concepts that are always relevant for fairness questions, especially in the environmental domain, it's also what happens with the environment, whether a policy is fair for the environment, but also for future generations that are very important factors. And so we're now interested in whether and how these different concepts are related with policy acceptance in Bengaluru and in San Francisco. I will first come to the study in Bengaluru. It's actually the same data collection as the previous one on the costs, risks, and benefits. So what I'm now focusing on is here that we also ask people about the perceived policy outcomes for the different groups of society that I introduced before. We also ask them how they perceive the fairness of this reuse policy and then acceptance of the reuse policy. You can see here the different groups that we considered in Bengaluru. So it's the respondent themselves, people covered by the policy, covered and low income, covered and vulnerable to water insecurity, then the entire population of Bengaluru and environment in future generations. And what we found is, first I start over here, is that perceived fairness was a key predictor of policy acceptance. So it's the higher the fairness was perceived to be, the higher was also the policy acceptance, and it's here a very strong association. So it's basically nearly the same. So if you find it fair, you also accept it. When we look into what explains fairness, perceived fairness, we actually find a difference between those who were covered and those who were not covered by the policy. For those not covered by the policy, the most important aspect was what happened with the people covered by the policy. So the more they perceive that the policy is beneficial, has positive outcomes for those who are covered, the fair they perceived it, and the more they then accepted the policy. However, for those who were covered by the policy, for them, environment and future generations were most important. So for them, it was the more they perceived that the policy is good for the environment and for future generations, the more they perceived the policy to be fair and accepted it. So what can we learn from this? The first point, fairness is really a key determinant of Sorry, now you can see this. Fairness is a key determinant of policy acceptance, and that's found again and again in the literature that policy acceptance is really very strongly interlinked with fairness, which also means that it really has to be considered when designing a policy. The second one is interesting here, maybe going back, so both aspects that we found were more kind of altruistic, you could say. So it was not a self-centered aspect that defined fairness. So for those not covered, it was what happens with the people who are covered by the policy. While for those who were covered by the policy, it was what happens with environment and future generations. And while this aspect, so the future generations and the environment, it's anyway part of the policy. I mean, the policy is there to remove environmental degradation. The implications for the people covered is something that really has to be already considered also when designing the policy. So when you have such a policy that creates unfairness, also implement measures that balance these out, which actually wasn't really done in Bengaluru. So with that, I will come to the case in San Francisco. So we also collected their data online, also with a panel company. In this case, we could only reach people not covered, and simply because there are not that many buildings there yet, and it's just too small a sample. We had here a bit of a different approach. We directly asked about perceived fairness for different groups of society, and then correlated that with the acceptance of the reuse policy. The groups that we had considered here are, again, the covered residents and also the building owners, because in this case it was mainly the building owners who were then also still responsible for the technology, the implementation, the population, again, low-income people, environment, and future generations. First, again, we have quite, so policy acceptance is very well explained by these fairness, perceived fairness aspects. So again, it seems to be really a key determinant of policy acceptance. When we look into which of these aspects predict fairness best, it's first what happens with the population of San Francisco. So when it's perceived as fair for the population of San Francisco, people also accept the policy. And then the second one, when it's perceived to be fair for future generations. I find it quite interesting that in this case, the people covered were not considered, while in Bengaluru they were. I can't prove that, but for me, it might be, part of the reason might be because in San Francisco, it's really high-income people who are only affected by it. And in a way, they can also afford it, and because of that, maybe it just doesn't matter that much. But yeah, that's just a speculation, you could say. Okay, so to wrap up this, so here again, we see that fairness is really a key determinant of policy acceptance and should therefore really be considered when designing policies. And in this case now, it was that the most important groups that were considered in this fairness assessment was the city, the entire population of San Francisco, and future generations. So what can we, when we now take this together, learn overall? So the first one is from the research on the technology acceptance. Benefits seem to be really key. So it's also in that sense important to focus on them and not only try to maybe downplay the costs or risk, but really work with these benefits. And this is for the policy acceptance there, as mentioned multiple times, fairness is really important and should be considered already when designing the policy. And the second one, in both of our studies, future generations were really important, and this can then really also be brought in when talking about the policy, what it really means for those future generations. To just give a short outlook, so this has been, so I've presented now previous research, but we are actually continuing this line of research. So we have now a larger project in Bengaluru where we are continuing looking into water reuse. And while so what I presented now was really psychological project, we have now an interdisciplinary project that has just started. So we have some engineers, we have also the transition group in our department, and then people working on governance. and us, the psychologists working on it. And what we are doing is now really doing this multi-perspective assessment there. And we are in work package 2, we are mostly looking into, so the engineers are looking into how can we optimize technologies there, while the transition people are looking into what would be good business models to increase acceptance, while we are then looking into what configurations of technologies and business models is most ideal to increase acceptance there. That's all I wanted to share with you. I thank you for your attention, and my collaborators, and especially Josine Coleman, who drove all this research.